behavior and the way we fly them. Remember that the Wright brothers appreciated that the basis for propeller design was the same as for wings, the subsonic aerofoil. When moving through the air, it generates a total reaction which enables an aircraft to fly. This is best explained by looking at it in terms of the lift produced by the aerofoil and the drag created by its resistance to the air. If the angle of attack is increased, more lift is generated, but at the expense of increased drag. Maximum lift being produced at the point of stall. A wing is usually at its most efficient at a relatively small angle of attack. In very simple terms, a propeller or air screw is really two or more rotating aerofoils set to pull the propeller through the air, in the same way as the thread of a screw pulls it into wood. During flight, its motion will comprise rotational velocity and forward velocity. With the propeller stationary, any forward velocity is that of the aircraft, the true airspeed. But a rotating propeller accelerates air and produces the induced flow. The sum of the TAS and the induced flow is the total inflow. Now the direction of the relative airflow can be plotted. But we know that to work effectively, aerofoils have to be set at a small angle of attack. The angle between the chord line and the plane of rotation is known as the blade angle or pitch of the propeller. The rotational velocity at the blade tip is faster than near the hub. And if the pitch remained constant, the angle of attack would increase towards the blade tip, possibly causing it to stall. So the blade is twisted to maintain a constant angle of attack. This is a fixed pitch propeller. It generates a total reaction in the same way as a wing. We know that the amount of lift generated varies with the angle of attack. It also varies with the speed of the airflow. The faster the airflow, the greater the lift. And vice versa. So in order to maintain level flight, when pilots alter an aircraft's speed, they also have to adjust the angle of attack to keep the lift constant and equal to the aircraft's weight. But whereas the speed of the airflow over a wing aerofoil is dictated by the speed of the aircraft, the airflow over a propeller is governed by its rotational speed, which is much faster than the forward velocity and virtually constant. Consequently, changes of forward velocity have very little effect on the speed of the relative airflow. What is affected by changes of forward velocity is the angle of attack and the consequent strength and direction of the total reaction produced. Remember that the total reaction produced by a wing aerofoil can be resolved in terms of lift and drag, and that the penalty for increased lift is increased drag. With a propeller, the total reaction is resolved as thrust, the force needed to overcome the drag of the airframe, and the propeller drag, or torque, which balances the power output of the engine. The penalty for increased thrust is increased torque. When a propeller is turning at a constant speed and the aircraft is stationary, the angle of attack is big, and large amounts of thrust and torque are produced. As the aircraft accelerates, so the angle of attack decreases with a consequent loss of thrust and torque. This continues until the reducing thrust equals the increasing airframe drag, when the aircraft has reached its maximum speed. The principal limitation of fixed-pitch propellers is that there is only one speed at which they work at peak efficiency. This propeller is a fine-pitch propeller. giving good performance for takeoff and climbing, but a relatively low maximum speed. By increasing or coarsening the pitch, the maximum speed can be increased. But there are practical limits to the size of the blade angle that can be used, since too large an angle might mean the propeller could be stalled when the aircraft is stationary or moving at low speeds. Torque would be high, so RPM would be low, and because the direction of the total reaction is further from the direction of flight, less thrust would be produced, and acceleration would be too slow for takeoff from normal airfields.